everyone, I am Prathamesh Shirsat. Today we discuss traversal method of a graph in which we point the method depth first search traversal. In a depth first search traversal, we start from one vertex and traverse the path as deeply as we can go. When there is no vertex further, we traverse back and search for unvisited vertex. Let me take one example for better understanding of the depth first search tree. Depth first search tree is used. It is one of the traversal technique of a graph. For that purpose, we can use stack. We all are familiar about stack. Stack, it is an data structure in which we insert a element from one end and also delete elements from same end. It is also known as first in last out. In DFS, you can take any node randomly as a root node, but if there is a mention the particular node as a root node, then that time we take that node as a root node. In DFS, at a time we insert one node and then further insert a node which is adjacent a node and take a node as possible as depth. Now we can take one example for better understanding of DFS. In this given example, here not clearly mention the root node, so we can take 0 as a root node. Then 0 having two adjacent nodes 1 and 3. But in a DFS, we can take a 3 because 3 is at a depth than 1. So for that purpose, we can move elements in a stack. Firstly, we move 0, then we take element as a 3. After 3, 3 is adjacent to two vertices, that is 0 and 4, but 0 is visited. For that purpose, we take 4 as a unvisited vertex and put 3 in a stack. Then for uh, for 4 there is a 3 and 2, but 2 is unvisited, so we take 2 as next element and put 4 in a stack. For 2 we take 1 as adjacent vertex and put 2 in a stack. Then likewise similarly we put 1 in a stack. In this example, backtracking is not used because this graph is not a complex and there is a simply means link graph. Then the output of depth first search tree is 0, 3, 4, 2 and 1. Let we discuss another example for better understanding. In this graph there are 5 vertices A, B, E, D and C. In this example also not clearly mention a root node, so we take D as a root node. Then because the in degree of a D is 0, then the D vertex is connected to all the vertices, but in a depth first search tree we can take adjacent vertex as possible as depth. So we can take a vertex after a D and put D in a stack. Then further we put A, then A is connected to B and E. But in a depth first search traversal we take B and put into a stack. Then B is further connected to C and A, but we take E and put into stack. Then remaining one, that is a C, that is also put into stack, and we get a final output as D, A, B, E and C. I hope it is nothing but a short solution of depth first search traversal. Thank you.